third graders. It's Wednesday. We're almost to the weekend. One more day. Remember, this is a short week, so we are going to do our DMA today and tomorrow, and you will have a quick check quiz tomorrow. I'm going to make it a short one so that way you can check your DMA tomorrow and have a little time to do your quick check quiz. All right, so let's take a look at our first problem. Remember, this is week 26, day 3. So I'm going to zoom in a little bit here. We're going to start with our first problem, which is 603 minus 277. So remember that when you are subtracting, the answer to a subtraction problem is called our what? Right, difference. It's called your difference. So let's take a look at, this is actually our standard 3.MBT, numbers in base 10. Remember, we're also remembering to fluently add and subtract. That's what you have to do in third grade. Fluently add and subtract within 1,000. So 603 minus 277, we're looking for the difference. So I'm going to start us off with 600 minus 200. And the difference, notice I said difference again, is 400. 400 plus 200 is 600. We can use that check. Now I'm going to take, I don't have any tens, but I need to subtract 70. Can I subtract 70 from 0? If I don't have money, can I spend $70? No. So that tells me I need to borrow 100 and regroup it as 100 here so that I can subtract. So what is 100 minus 70? Well, 10 tens is 100. So that tells me I have 10 tens minus 7 tens, because that's what 70 is, 7 tens. So 10 tens minus 7 tens is 3 tens, or 30. And 30 plus 70 is 100. Now I'm going to subtract my 1, so I have 3 minus 7. 3 minus 7. Can I subtract 7 from this 3? No, because I do not have enough ones to subtract if there's only 3. So I'm going to, again, borrow a 10, and I'm going to take that 10 and add it to 3 to make it 13. So now I have 13 minus 7. Now I can subtract. So this would leave me with 6. So 320 and 6 together, 300 plus 20 plus 6 is going to give me 326. So I put that all back together as 326. Hundreds, tens, ones. Notice how I have them all lined up underneath each other in rows to keep it organized. Now let's work on using the algorithm. So if I had 603 minus 277, well, I start in my ones place, and if I start in my ones place, I need to realize that I cannot subtract 7 from only 3. If I only have 3, I can't subtract 7 from the 3. So that means I need to borrow, but I don't have any tens to borrow here. So where can I get some tens that I can use to borrow? Well, I can take 100 and make it into 10 tens. So that means that I'm going to take that 100, and regroup it as 10 tens. And I'm just going to show that with a different colored pen here. So now that 100 that I borrowed from here is now going to become 10 tens, because 10 tens is 100. Now I have some tens. Now I can come back and regroup and borrow a 10, and now add it to 13, which is what I did here, And now I can subtract. So I have 13 minus 7 is going to give me 6, which is what I did here in my ones there. Same thing whenever I regrouped here. I had to borrow to make this 100 and subtract 70. But when I borrowed this 100 or 10 from here, I actually borrowed it from my answer instead of right there, which I could have borrowed it from here, but I decided to borrow it from here instead. And this is going to be 90 minus 70 is 20, which is here. My 500 minus 200 is going to be 300, which is here. So I have my 326. Same thing, used my algorithm. I had to do some borrowing here, just like I did here. There was regrouping. No matter how I did it, I had to regroup. Okay, let's check our answer. How do we check? Well, we have a part and a part, and when we put these parts back together, we make the whole. So if I take this 326, which was part of this number, and I take the 277, which is my other part of this number, 603, and I put them back together, they should add up back to 603. So 6 plus 7 is 13. Carry the 10. There's that 10 again. 70, 80, 90, 100. Regroup that 100. And that's when I had to borrow. Remember, I had to borrow that 100 and regroup it. Well, now I'm adding it back in. 300 plus 200 is 500. Plus one more 100 is 600. 603. So that means I did my subtracting correctly if it comes back out to the addend. Or when I take these addends and add them back together, it starts and gives me my total, which was 603. Okay? Now, let's take a look at our next problem. The next problem is comparing two fractions. I need half, or each one of these is half. So that's a unit part, right? This is my unit part, one of the parts, unit part. And each one of these unit pieces is 1/4. 1/4 is each one of those parts, one of the 4 parts. Now, they want us to take 1/2 and compare it to 1/4. What do we know about 1/2 compared to 1/4? Well, remember, if you take a whole and cut it into 2 pieces, and you take that same whole and cut it up into 4 pieces, your halves are going to be larger pieces because fewer pieces makes bigger pieces. Okay? So 1/2 is going to be greater than 1/4. Now, for your discussion question today, what I want you to do is I want you to tell me how many more pieces would you have to shade in to make this equivalent to half. So how many more of these 4ths would you have to shade in to make it equal to half? Okay, how many 4ths would it take to make it equal to half? All right, let's take a look at our next question. It's a measurement question. And I'm going to zoom in because it's a little hard to see the fractions in between these whole numbers. Remember, a ruler is a number line. And it's got whole numbers on it. 1, 2, 3, 4. We could continue going. Remember that fractions are between your whole numbers. So I'm just going to show you where half would be. So half is going to be right there between the 0 and the 1. Half is going to be right there between the 1 and the 2. And half is going to be right here between the 2 and the 3. And if I was going to do half again, it would be between the 3 and the 4. Now remember, you can take your halves and cut them into 4ths. So right here would be a 4th, 2 4ths, 3 4ths. So your next longest line are your 4ths. this would be a fourth, and that would be a fourth. This would be a fourth, and this would be a fourth. And that would be a fourth, and that would be a fourth. Now, between your fourths are your eighths. I'm not going to label those because in third grade, we really don't have to worry about eighths, but we're going to talk about them since we do talk about cutting fourths into eighths, but I'm not going to label them. So this would be 1/4, 2/4, which is half, and 3/4. Remember, 4/4 would be 1 whole. Then you have 1/4 again, half, and 3/4. And then you have 2 whole. And then you have 1/4 and half and 3/4. But since we are stopping here, I'm going to stop there when we go to write our measurement. So we have 2 whole inches, and then from 2 whole up to here is another half. So when we write our measurement, we're going to write 2 as our whole inches and half of another. Now, if you notice, we could also write with just the numerator and the denominator. So how many halves does it take to make 2 1/2? Well, we have a half here, that's 1. And when we get to 1, that's 2 halves, 3 halves, 1 half, 2 halves, 3 halves. When we get to 2, that's 4 halves, and 1 more half is going to be 5 halves. So if you remember, I'm going to zoom out here. Remember this sheet? Well, I have 1 whole, so I have 1 half, 2 halves, 3 halves, 4 halves. Now I'm at 2 whole, which would be 2 whole inches on my paper, and then another half makes 5 halves. So 5 halves is the same as 2 1/2. So 2 1/2 up to here, 2 1/2 is equal to 5 halves. Okay, we can see that. 1, 2, 3, 4, up to 2 would be 4 halves, and then 1 more makes 5 halves. So let's take a look at our next problem. Our next problem is a word problem. Morgan wants to test drive a car and needs the key. Wow, needs to look for a key and a whole bunch of keys, it sounds like. Each key ring has 6 keys. So each key ring has 6 keys. If there are 9 key rings, how many keys are there total? Remember, we're not adding keys to key rings. They're not asking us how many keys and key rings there are. They're asking us how many keys there are. And so we're taking the key rings, those are the groups, and we're putting 6 keys on each key ring. So that's 9 groups of 6. And 9 groups of 6 means that we are using what? Multiplication, right? We're not sharing the keys. We're not taking the keys and putting them onto the key rings to find out how many keys are on each ring. We already know that information. We want to find the total. So if we're looking for the total, the groups are the key rings. And I have 9 of them. I have 6 keys each ring, on each ring, and I'm looking for total keys. So normally I would use bars, but to kind of keep with the idea of rings, let's say this is a ring, 2 key rings, 3, 4, 5, 6, 7, 8, 9. There are 9 key rings, and each key ring has 6 keys. So I'm going to put, so we're looking for keys here. How many keys are there? So I'm going to put a K there. For keys. Now I can add all of these together. Oops, K. I could add 6 plus 6 is 12. 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 And then I don't have another 6 here, so that's just 1 6 by itself. 10, 20, 30, 40. So I have 4 10s, which is 40. Now I can count by 2s. 2, 4, 6, 8. Now I need to add 8, and 6 more is going to be 14. So 40 and 14. Well, 40 and 10 makes, right, 50. And 50 plus 4 makes 54. So there are 54 keys total. So my K is actually equal to 54, right? 54 meaning how many keys there are. Now, remember, you could also do 6 groups of 9 or 9 groups of 6. So I could add groups of 9. I could go 9, 18, 27, 36, 45, 54, right? 54, it would be 6 groups of 9. So that would also be a way that you could think about it as well. If you switch the factors and then multiply, maybe add groups of 9 might be easier for you. But now we can take our answer and say there are 54 keys because 9 groups of 6 added together makes 54. And now you've shown me a model. You've written an equation to show how you would solve it, and you've given me a response by showing that in my equation. Okay? So have a great Wednesday. Don't forget to do your happy numbers for 20 minutes because those lessons work with your fractions, and fact fluency for 5 minutes. Okay, guys? Also, I'm going to put that video in to make sure that you check your page 261 where we left off, and we will see you on Thursday. Have a great Wednesday, guys, and see you tomorrow.